Hello everyone. Today I'm Taran Kai Patel, a proud member of EM Wing, is now going to explain you fundamentals of forensic science. Today I invite you to delve into the fascinating world of forensic science, a discipline that is as thrilling as it is crucial. You have probably encountered forensics in various television shows or movies where brilliant detectives solve crime by piecing things together. While dramatized, these portraits underscore an essential truth. Forensic science is the linchpin of modern criminal investigations. As it is core, forensic science is the application of scientific principles to legal questions. It provides evidence necessary to uncover the truth and administer justice. Without it, our courts and investigators would rely solely on testimonies which could be based, unreliable, or even fabricated. The integration of science into the justice system offers something invaluable, that is objectivity. During the next 15 minutes, I'll guide you through the basics of forensic science, explore the different types of evidence it uses, discuss the key techniques, and reflect the ethical challenges and future potential to this vital field. What is forensic science? So I'll just introduce about what is basically forensic science. Forensic science is a multidisciplinary field encompassing biology, chemistry, physics, and even digital technology. Its aim is to simplify profound, to collect, analyze, and interpret evidence to solve crimes. Forensic scientists are the silent heroes behind every investigation. They don't chase suspects or interrogate witness. Instead, they focus on what evidence tells them. And evidence never lies. A bloody fingerprint, a strand of hair, or a single fiber can reveal the truth behind even the most, uh, we can say, the most baffling crimes. Historically, forensic science has been like around us since centuries. Ancient Chinese texts describe the use of fingerprints for identification. In the 19th century, Europe, pioneers like Alphonse Belton and Sir Francis Galton laid the groundwork of modern techniques such as anthropology and fingerprint classification. Today, the field has grown to include everything from DNA to digital forensics, transforming how we solve crimes and proving its worth as cornerstone of the justice system. Types of evidence in forensic science. Now, let us understand what are the types of evidence. What is mainly the physical evidence and what is the mainly digital evidence. So, evidence is the thread that ties the suspect to the victim and the crime scene together. Forensic evidence can be classified into two broad categories: physical evidence and biological evidence. So, first we'll see what is physical evidence. Well, we'll understand what is physical evidence. Physical evidence refers to non-living or like material or objects. This type of evidence can often be visible to the naked eyes and can provide complementing links between crime and those involved. Examples of physical evidence include fingerprints, weapons, tool marks, and clothing fibers, and much more. Like in fingerprint, if you see, these are found on surface like glasses or doorknobs. Fingerprints are unique and they are like irreplaceable. Like if we say each one has a unique fingerprint pattern. No fingerprint is identical, not even the twins fingerprint. Weapons like guns, knives, or blunt objects can reveal clues about the crime, such as force used to direct or impact. Tool marks. These indicate forced entry or tampering, often linking to suspect to scene through a specific tool or method. Like a suspect uses a primary, we say a tool, like to break the door or something else like the same. And clothing fibers. Even the tiniest fiber or tampering often linked to the suspect to the scene through specific fiber. Like if there's something like if you find a piece of fiber there on the crime scene, and we can link the same fiber to the suspect's cloth. So, like linking the suspect and the crime scene together. Second one are the biological evidence. Biological evidence are derived from living organisms. Like it's often more intimating and telling. Like it can be establish direct connection between individuals through genetic materials. The types of biological evidence include blood stains. Blood stains mainly include like patterns and chemicals analyzed of the blood can determine how the crime has been occurred. Second one is the DNA. The gold standard of forensic evidence is DNA. DNA is extracted from the hair, skin, saliva, or body fluids. Its accuracy has overturned wonderful convictions and resolved cold cases. So, like the next one is the hair and the skin cells. Trace evidence often is invisible to the eyes, but they still hold crucial genetic information. Like, for example, in 1995, DNA evidence played a provisional vital role in the O.J. Simpson trial, showcasing its power in high case profile cases. Like, it's also very important evidence. Uh, Now we'll move forward to like forensic techniques. So, forensic scientists employ a wide range of techniques to analyze evidence. So, let's explore the most prominent methods. First one is DNA profiling. DNA is unique to every individual except identical twins. By comparing DNA samples, the crime scene to a suspect, forensics expert can determine very clearly whether the individual was involved in that crime or not. For example, the case of Golden State Killer involved in 2018 is a prime example of power of DNA profiling. Decades-old crimes were resolved by using this DNA profiling method. Second one is ballistics. Ballistics experts study firearms and ammunition. They can determine whether a bullet matches a particular weapon and reconstruct the trajectory of that firearm, offering insight to sequence of shoots in events. Like in ballistics, if you find a particular bullet on the crime scene, so we can relate to the gun that has been used and we can reconstruct the crime scene. The third one is trace evidence analysis. This mainly involves the examination of small objects like such as fibers or pollen grains or transfer between individuals or like something if you like there is some pollen grains on anybody's hands. So like due to the physical touching or some these things, the pollen grains get exchanged. Such evidence often provides critical links when no direct evidence is available. Like if the criminal shakes hand with the another person, so like we can analyze these pollen grains and match the pollen grains that are found on the suspect's hand. So like it can have a direct connection between all these both of them. Going to the next one, that is fourth one is the toxicology. Toxicology focuses on detecting like drugs, alcohols, poisons, and other substances in body fluids. It's essential for cases involving overdoses or like suspicious chemicals. So now, like these are the trace evidence. Trace evidence like are mainly very vital in the clues. Like like, they link the suspect or the criminal to the crime scene. Now, going to the role of evidence in criminal justice. So, evidence in criminal science can be divided into direct evidence, circumstantial evidence, testimonial evidence, and documentary evidence. So, we'll understand all four of this. So, first one is direct evidence. What is direct evidence? Evidence that straightforwardly provides a fact, such as video, footage, eyewitness, or testimony. It is known as direct evidence. Like if there is a person A who has seen the crime, crime happening. So the person who's seeing the crime will be the eyewitness, or he will be the testimonial evidence. Second one is the circumstantial evidence. What is circumstantial evidence? Evidence that implies a fact without direct proving it, like finding the suspect fingerprints at the crime scene. Like if there is a particular crime scene happened, the evidence that the fingerprints that are found on the crime scene, they are directly or indirectly connected to the suspect's fingerprint. So it can be said or it can be categorized under circumstantial evidence. Third one is the testimonial evidence. Statements made by the witness or experts. Forensics expert often testify in court explaining their findings. Testimonial evidence are the evidence which has a vital proof or which has a scientific proof which are given by the forensic experts. And third one is the documentary evidence. Written or recorded materials such as contracts, emails, or crime scene photographs. Documentary evidence are mainly the evidence which are found on the crime scene. That includes photographs, letters, or the crime scene photographs that are clicked by the forensic the which the photos are clicked on the crime scene. Each type of evidence straightens a case, but forensic evidence is more often seen as the most reliable because it has a vital proof behind each evidence. So now, what are the ethical challenges in forensic science? The power of forensic science comes with great responsibility. Errors, biases, or unethical practices can lead to wrong consequences, such as wrongful findings. The challenges includes mainly are contamination of evidence, basis in analysis, and chain of custody issues. So the mainly the problems in the ethical challenges in forensic science include the first one is the contamination of evidence. Contamination of evidence mainly occurs due to the improper handling of the evidence. Uh, like someone like if the evidence is a particular evidence, if touched by another person, the fingerprint will often be visible. The person's fingerprint will be visible on that evidence. So the evidence again become contaminated. Second one is the basic analysis. Expert must retain impartial even when working with law enforcement. And the third one is chain of custody issues. Every piece of evidence must be carefully tracked to ensure its authenticity. Like in some cases, the chain of custody is broken. Chain of custody is the documentation of evidence from the time it is collected to the time presented in the court of law. So if the chain of custody is broken, the evidence has no value or the negligible value. To cut down these cases, forensic scientists follow strict protocols and adhere ethical standards to ultimate goal, to not tamper the evidence. Uh, Now we'll move on to another topic that is emerging topic that is the uh, forensic uh, we'll go to cyber forensics. So cyber forensics is the most advanced topic. The field of forensic science is never uh, slowed down, or it is, we can say, ever evolving. Thanks to the advanced technologies, here are some of the exciting developments. First one is the artificial intelligence, AI. AI is now being used to analyze vast data sets, identify patterns, and even predict outcomes of the different samples that are found on the crime scene. Second one is nanotechnology. It allows for the detection of evidence at molecular level, opening up possibilities previously unimaginable. Like nanotechnology is a something is a thing that it allows the detection of evidence at a very minute level, at a very small molecular level. Third one is the digital forensics. Digital forensics with rise of cybercrime. Digital forensics is becoming indispensable. It deals with recovering and analyzing data from electronic devices, like recovering the call logs or location history of the criminal, or we can say the app data that the criminal from the phone that the criminal is using. So the future promises of a forensic science that is faster, more accurate, and capable of tracking most complex cases. So these are the challenges that I explained you: global collaboration, all these things. So I concluded by that saying that the importance of forensic science in modern technology. To conclude, forensic science is much more than the stuff of TV dramas. It's a vital tool for justice. It combines science, ethics, and legal principles to uncover the truth. From analyzing fingerprints, it has revolutionized how we solve crimes. As society evolves and new challenges emerges, so too will forensic science. It pursued the truth, unwavering, and role to ensure justice will remain indispensable. Thank you for your time and attention.